Okay, we continue with the speculum map. Okay, so for this speculum map, okay, last time I'm using shader graph to come out with the result like this. Okay, so what is the speculum map? We all know that the speculum map is specular. It means that the lightings are toward it. Okay. So this is the specular map that if you have the leaf, maple leaf here. Okay, so now, okay, we are using the shader graph. Okay, sorry.
This texture mapping method allows parts of an object to have a specular effect. Specular map define where light should reflect more or less. A specular map is a type of texture map used in 3D graphics to control the shininess or reflectiveness of a surface. It's typically a grayscale image where white areas correspond to shiny highlights and black areas correspond to matte or non-reflective areas. Here's a breakdown of how specular maps work. White areas, these areas of the specular map will be the most reflective parts of the material. When light hits these areas, it will be reflected at a sharp angle, creating a bright highlight. Black areas, these areas of the specular map will be the least reflective parts of the material. Light hitting these areas will be scattered in all directions, resulting in a dull or matte appearance. Gray areas, areas of the specular map that are in between black and white will have varying degrees of shininess.
Okay, so this is the grayscale that I have. Okay, with the sample textures and we outcome like this and we attach and it will look like this lah. So we wanted to make it the outcome like this. Okay. So first, the shape. Okay, we need the maple leaf lah. So we can go for. Okay, so download the maple leaf, black and white. Okay, so for the shininess, we wanted to have our maple leaf. Okay. Okay, so we have the maple leaf, but this is the maple leaf that it will be the another way side. So we need to invert lah. So means that the shininess will be the white and the black here. So either you can use coding to manipulate them or you can use the Photoshop to help you. So this one we can get the maple leaf. Okay, open your Photoshop. Okay, open your Photoshop. Okay, so now this one is the black colors. Wait, so behind we need to have a black color. Okay, this one we need to invert them now. So select the subject. So we select the subject here. So select this one. Right click, layer where copy. So now we have this. This one you can delete it. So for this one, from the black, you need to change to the white. So this one you can make it like white color. Okay, so now you can combine them, merge layer, and now we do the adjustment. We invert them, Control I. So now we invert something like this. Okay. So same thing, we export to this one. We export to JPEG will do. So the maple leaf BW black and white. See. Okay, so we try to have a grayscale here. So we can select the subject D. So select color range, we select this one, and we wanted to make it layer where copy. Okay, we make it like grayscale. So we can have a gradient overlay here. Then you can have the grayscale. Okay, so the outcome grays. Okay, so something like okay, it can be the angles. Oh, we're using this one. Okay, so the gradient, I think we're using this one. Okay, something like this. So the inner one we make it more white, outside we more darker. Okay, you can see this one. Okay, we're using this one. Okay, so now we export to JPEG. Okay, this is our outcome. So maple leaf, grayscale. Save. So you have this. Okay. Oops. We need to open our. Can we use coding to modify it to make it smaller? Okay, so we can make it smaller a bit now. Okay, this one here. This one. I'm still recording. Easiest lah. Easiest to modify here. So then we have a black colors. Add one more layer, black colors. So this is, we make it smaller a bit. Then to have a specular effects. So export to JPEG. Export. So Maple Leaf small. Save. So now we put it this one. Okay, we replace our image to make it smaller a bit. So now it will be have an effect like this, the speculars. Okay. Okay, to get these effects, okay, to cut out this one, so what we need is we need to have a transparency. So export PNG, Maple Leaf, PNG, save. So drag and drop with our Maple Leaf PNG here. Okay, the surface type change to transparent and alpha clip, then size both. Okay, that's this one. Shader graph not really lah. Okay, so for the specular it look like this. Okay, our Maple Leaf. Oh, okay, so this one, so we have the alpha, so we need to plug to the alpha value and also the alpha clip threshold. Okay, the new one, because previously don't have this. Okay, this new version you need to plug to the alpha and the alpha clip transparency here. So now the effect will be better. Save again. Attach the alpha values to alpha and then this to this. So now you try with your things. It will look like this. It will look like this. Alpha clipping. Still got the transparency outside, huh? Alpha, I click already, oh, still. Still got a transparent value. Okay, we make it transparent. 8%. Still. Alpha. So for the shader gap, it still have this. You still can see the transparency value here. You can see it still have a transparency value here. Okay, how about if we so we continue with the height map. Okay,
Height mapping, also known as parallax mapping, is a similar concept to normal mapping. However, this technique is more complex and therefore also more performance expensive. Height maps are usually used in conjunction with normal maps, and often they are used to give extra definition to surfaces where the texture maps are responsible for rendering large bump protrusions. While normal mapping modifies the lighting across the surface of the texture, parallax height mapping goes a step further and actually shifts the areas of the visible surface texture around, to achieve a kind of surface level occlusion effect. The main advantage of using height mapping over normal mapping is its ability to achieve surface level occlusion effects. This means that apparent bumps will have their near side, facing the camera, expanded and exaggerated, and their far side, facing away from the camera, will be reduced and seem to be occluded from view. This effect, while it can produce a very convincing representation of 3D geometry, is still limited to the surface of the flat polygons of an object's mesh. This means that while surface bumps will appear to protrude and occlude each other, the silhouette of the model will never be modified, because ultimately the effect is drawn onto the surface of the model and does not modify the actual geometry. A height map should be a grayscale, with white areas representing the high areas of your texture and black presenting the low areas.
Okay, you can see this is the difference after you implement the bump map. Okay, so this one is just the fill map. Okay, and this one is the normal map aside, and this one is the high map. So you can see the occluded part here, so it will be more darker here, so it will be have a high effect. High effects, okay, so we all know that okay, take this grayscale as an example. So you can see this one will be the darker one, so means that it will be low area and this one will be the high area. So this one is the example of the high map. Okay, we take the example of the high map, so we can go for free texture mapping. or 3D texture.me here. Okay, for example, we have the brick. Okay, example of brick. Okay, we take this one, the stone here. Okay, so it will have the normal displacement, roughness, and ambient occlusion. So we download all the maps. Okay, so we take this one as an example. Unzip it. Okay, so this one you can see ambient occlusion. Base colors means that our diffuse map, and this is our normal map, and this one roughness, and this one is a high map. So you can see the high map means that this one is a darker area, so you can see more apparently. So first we implement our wall here. We take this one, we put this texture, our structure prefab here. Okay, so we right click create material for our wall. This is our wall. Okay, so we just drag and drop all the image for a brick here. You can have folders. Create folder wall here. Okay, so now you drag all of them inside. Okay, we create a material. Okay, so wall map. Okay, so the first, this is the base color, so we just place it as our base color, and we implement to this one. Okay, so now we have the wall is look like this. So you can see it's very flat, correct or not? So if we implement a normal map here, you can see it will be more apparently you have changes already, right? So like 0.1. Okay, so you can see the bumpiness here. Okay, normal maps, grayscale, like. To 0.1. Why so not very nice? Okay, so if we copy from this, the auto one, normal map, grab from this one, smooth, apply. Okay. I think much more comfortable to look at, right? Okay, so below specular. Okay, so the smoothness is 0 because we are wall the brick, so the roughness is very high. Then we implement the height map, okay, the height map. So we can make it more, so we can see the changes. Okay, this one, change the normal map. Okay, great. Apply. So now you can feelings like you have the height map. Can see it will be protrude out. The effect of stone will be better, sir. Okay. Rock one, we get this one. Remove already. So we try with the material wall stone. Wait, so many wall stone. Rock stone is it? Same na. 25. Oh, this one. Hả? Chúng ta ăn chip đó. Oh. Okay, right click, create material, rocks wall. The base one. Okay, the ambient occlusion high map, normal map, normal map. Okay, this one better. Okay, so normal map and then the high map. Okay, so you can adjust bigger a bit the high map. So now you can see the stone for they have a high effect already. So when we make our high map to lower, bigger, so you can see the changes or not. Okay. Then we implement our occlusion map. Okay, so it will be look like this. So you can see your stone. Okay, it will protrude one. Okay, so next we have the occlusion map. So occlusion map is about...
The occlusion map is used to provide information about which areas of the model should receive high or low indirect lighting. Indirect lighting comes from ambient lighting and reflections, and so steep concave parts of your model such as a crack or fold would not realistically receive much indirect light. Occlusion texture maps are normally calculated by 3D applications directly from the 3D model using the modeler or third-party software. An occlusion map is a grayscale image, with white indicating areas that should receive full indirect lighting, and black indicating no indirect lighting.
Okay, so the simple is the grayscale. So when it white indicating that you receive full indirect lighting, and black indicating no indirect lighting. So in between is depends on how near it to be white and how near it to be black. So this is the example occlusion map, indicate the area of a character's sleeve here, so exposed or hidden from the ambient lighting. So you can see this one is without the occlusion map, so it receives all the indirect light, okay, because of ambient occlusion map. So after we implement the ambient occlusion map, so you can see the face back from the light, it will be darker. He didn't receive the indirect light. Okay, so you can see entire will be for more nature and more to the realistic after we implement the occlusion map. So you can see when we draw the occlusion map, the winkles, right? So this one is the upper part, okay, so it will receive all the indirect lighting, and these areas is the winkles inside, so means that it will be more darker area. Okay, so you can see this part will be darker and this one will be brighter, okay, for your game. So for your wall as well, you can see this one inside will be more darker. So when you implement your ambient occlusions here, you will have a darker part surrounding this area, okay, and this high area it will be reflected more indirect lighting, it will be more white. Okay, so we can implement the roughness as well. For the unity, roughness we'll put inside the metallic here. Okay. It will be goes to albedo. So you can see this is the entire fittings once you implement lah, it look very comfortable lah. If we remove all of this, you can see the entire feelings will be very flat and not nice. Correct or not? Okay, so you see very flat. So once we implement the normal map, okay, once we implement the high map, okay, we implement the occlusion map, the entire feeling is very comfortable and look clear. We no need to use, actually this one is just flat only, flat area, but we can see they are not flat. So when you walk through the entire wall, so the stone here, it will be very comfortable, so you can see it look clear. Okay. So now we will discuss about the growing map. So this growing map, for example, like our TV lah, okay, the material that we will be emit the light. Okay, for example, your lighting, your bulb, okay, so it will emission. So you can see this is the normal textures without a grow image, and this one you can grow your image like a rainbow colors here. So we can download the rainbow texture. Okay, wow, this one very nice. Okay, we can use this one. Okay, rainbow emission for this. Okay, so we can have the rainbow emission here. This one. Okay, so we can create an emission image. Sorry. Okay, the material for the emission. Okay, so now we put it in our base, so it will look like this. It will look like this without the emission. Okay, so now you check this one, emission. Okay, you can have two. Okay, so for this one, we using the Y if we implement our emission here. So you can see the emission and non-emission here. So if you want it more apparently, you can close all the lighting. Okay, so you can look at this. Okay, play it in your game. So you can see the emission will look like this. Okay. So for your emissions, for example, I don't want a certain part of it will emitted. So I goes to the part to my Photoshop. Okay, I'll do something to my Photoshop. Okay, so I'm using the black colors. I don't want this part to emit now, so I'm drawing. Okay, and this part I don't want to emit. Okay, so this is the part that I don't want to emit, so I've used the black color. So I export it to JPEG. Okay, export it as a mask that I don't want to emit it. So now I'm goes to the material of my emission. Okay, so have this image. So I put it here. Okay, so now you can put it this part. Okay, you go and play. Okay, now you'll notice that a certain part of it you won't have the emissions. White color is back color. So okay, put it this one. So you can see the emission part. So you can see the darker part. Okay, so now you have these effects that the certain of the part you see it will emitted, white color will be emitted, and the black color is won't emitted lah. Because this one is not black enough, so we can have the image that this one. For example, let's try with this outcome. Okay, so we can see the emission part. So this is the part that is didn't do the emissions lah. We have this. So this one. But so this one we can make it 2. Okay, so the emitted part and not the emitted part. It's a transparent, so how about if we make it like transparent? Okay, I'm doing this. Select the color range here. So now I'm this part, and I copy this part and make it transparent. So save as rainbow emission image. So we try do different pattern and test the outcome. Okay. Yeah, series export to JPEG. Export. So rainbow emission leaf shape. Leaf mask. So let's try. Have this. So I'm putting here. So let's see. Okay, so now it will be emitted like this, the transparent one. Not really nice also. So how about if we black color behind? I want this one will be brighter. Okay, and then I'm use this one. Okay, so change different type of the outcome and see the difference. So it will look like this. So not so nice. Okay. Next, so this one is a growing the part that we wanted to on and off. If we have this one, okay, so I can see if we have this one, so it was something like this. Animation part. The intensity. So we can adjust until you feel okay. Okay, so I'll feel like this. Okay, next. This one can be your. You see, this one is the emission. Okay. So if you are doing like horror game, ghost game, zombie game, so the darker part, right, you can put some emission things to make it nicer lah. So this one, so you can see this is the part that you do. Okay, the black color is using the black color, and the part that you want to do emission. So try again. Black color be high. Okay, so export JPEG, export, so invert. Okay. So for this one, emission here, so make it like that. Okay, you can see only the leaf part will be emitted now, the outside is not emitted. Okay, so we can make it even brighter, like 6. So you can see class, so now the emission part will be the leaf part, focusing of the leaf part. If I'm doing like this, okay, so it will look like this. So it will be emitted this part only lah. Like this, nice. So if we only want this, and then the cube we don't want, so we need to have a transparency, this one. Okay, export as a PNG, export emission, transparent, safe. Okay, so transparent. A okay, this one. Hey, like it. Okay, this one. Transparent. Okay, alpha clipping. Okay, both side. So you can see now you can have this so only the emission part. So you can use this one for your horror game, so you emit a certain part only. So not like your entire scene is too dark. And you don't want to put the light, okay, you can put the emission for your object. So the word. Okay, so next. Okay, this one is a refraction map, so it will reflected for the unity one, the refracted one actually can see the news okay, the game object with the spheres here. Okay, now you have the material, so refraction, material, refraction. Okay, so if actually you put it like material like this and you have a smoothness, you will have the 3D cube here, okay, which is the map, okay, see 3D cube, but we already modify and it won't changes, so because it's get the default one environment refraction. Okay, so this one you need to change to like the 3D models with 在哪里哦 refraction probe here. Okay, so the type is the real time, so every frame refract the probe here. Refraction probe, and this one is your sphere. Copy the wall transform. Okay, paste the wall transform. Okay, the size is 1:1 and the size is 1:1. So still this. Real-time refraction probe disabled in the quality setting. Okay, so when you walk through here, the reflection probe, every frame important. Okay. Wait, Unity 6 a bit different. So Refraction Pro quality setting. So for Unity 6 will be more step compared to the previous version. So for Unity 6, you need to go to edit project setting and then goes to your quality here, okay, and check this real-time refraction probe. So now you see it will be refracted your sky already and your environment. So you see your characters are, when you walk around class, you can see it will be walk around as well. So this one is a refraction texture mapping. Okay, this one can do. Okay, so for the sphere refraction, we open a 3D object Sphere first. Okay, we call it as a refraction. Okay, can. So now you have a refraction ball here. Okay, actually the refraction ball, it will be automatically detect already, the refraction. Okay, you have a material with it. So you drag to this refraction ball. Actually you goes to smooth metallic to 1, and the smooth is 1. It will be have the previous already, the sky box already. You can see? But this is not real time yet. It's just a 6 cube only. This is not what we want. So we goes to refraction. We create the light and we call it as a refraction probe here. Okay. So now this is your refraction probe. Okay. Okay. So this one refraction probe we change to real time. Okay. We change to real time. Okay, if you do not have this, okay, if you steal the previous one, the sky, goes to edit project setting, go to project setting, you see the quality here, you check this one, project setting, quality, and real-time refraction probe. So now you have your refraction probe already, you see? Okay, and this one we change to real time. Okay, if you back, it means that it only have this, the normal one. Okay, the previous one, and the the custom is you custom yourself, and then the real time, the Unity will be calculate for themselves. And refraction mode is, this one is on wake only. Okay, this one is every frame. So if you have on wake only, you see, when the person is walk by here, it don't have any effects because it's only called the first time. But if you humans if your humans, okay, in front of your human, okay, so first time when you awake it, okay, you use the awake, so you see it will be the starting the first point, the first one only. Okay, the first time only. So you change to every frame. Every frame means that every frames are, okay, every changes, okay, it will be updating. So now you can walk through it. So you can see your characters walk here and it will surrounded. Okay. Any issue? Okay, next we'll have the secondary. So the secondary actually I'm not really advise you using the secondary because it's very expensive lah. Okay, because this one is a detailed map lah.
Secondary maps, or detail maps, allow you to overlay a second set of textures on top of the main textures listed above. You can apply a second albedo color map, and a second normal map. Typically, these would be mapped on a much smaller scale repeated many times across the object's surface, compared with the main albedo and detail maps. The reason for this is to allow the material to have sharp detail when viewed up close, while also having a normal level of detail when viewed from further away, without having to use a single extremely high texture map to achieve both goals.
Okay, so normally advise not to use this one unless you wanted to be a very realistic, so then you can add the detail one Okay. So try not to always use the secondary. And this one is use more than one texture mapping. We already show you how to do. This one is a hypertextures. Okay, I think it's the last one already. Okay, this one is the texture tiling. Sorry, this one is the texture projection. So for this texture projection, oh my god, I also okay. So I think it's the okay. We goes to object and we have a light. We goes for the spotlight. Okay, for your spotlight. Okay. So this is the spotlight. For example, I make it intensity higher a bit so we can see it more clearer. Okay, so the range the inner and outer, we make it bigger a bit so easy to see. Okay, so for this cookie, okay, the projecting that you wanted so you can use the real-time indirect spot shader only support for directional light Oh, now don't have already. Real-time indirect bouncing. So try this. Okay, you can see it will be like the projecting. Can you see the difference? Can you see? I'm projecting the different things inside. Okay, you can put the cookies here, so you can have a project something here. Okay, so if I project okay, you can project any image here, so you can see now you projecting already so you can make it higher intensity so you can see the things that you are projected. Okay, make it bigger, smaller. Okay, indirect, no, not much issue. The range 1 12 so like this will be better. Can you see the textures projecting? Okay, for projecting you can use the spotlight. Okay, and then you have a cookies here. So area light don't have okay, so he say the cookies must be the square width and height must be equal. Okay, so but it still can have the outcome Okay, you need to have the same here. So new 500 times 500. So you want to project the love shape. Okay, for example, export as the JPEG. Export it. Love shape. Yeah, we can have the love shape here. The projectile cookies. So now you have this. So the love shape. So how about if we have a transparent? So we draw. We draw love here. Okay, very ugly. So export as love transparency. So we can try see how unity is. So love shape transparency here. Okay, so if we have a transparency value for our cookie, it will look like this. Can is it our class end already? Okay, so 10 minutes. Okay, this one is a tiling. Okay, class, you can look at this. If we have a tiling, for example, just now, okay, so we have any image or not? Okay, so now we have the tiling material here. Okay, tile. Okay, so if we implement our love shape here, okay, our love shape, okay, we implement to one of our cube here. Okay, now only one love, right? Okay, so for tiling you can put it 10 10. 10 10. So now you can see it will be 10 times 10 tiling already. Okay, if you have 2 2, so tiling like this. Okay, if you have 4 4, so it look like this. So this is tiling. Offset, it means that it goes to the left a bit or right a bit. Okay, and then up down. So this one is means offset. So if you want to make your things okay, it will be like moving down. Okay, so you use coding by time to move the offset, so it will be moving. Okay, so just like your waterfall or your lava, okay, it can move your textures. This one will be discussed next time. Okay, we'll do tutorial for next time. Okay, so this one is tiling. Okay, so this one is a seamless texture. Okay, you can see your actors. Sometimes you can see it will have the very can have a seam here lah. So to do a seamless, okay, this is a suggestion of the tutorial. Okay, that you can do the seamless. So I don't have time already. I just saw the video. So he will be very easy on me. He bake it as a form, this one, and then he will just fill the thing, so he will feel like it's seamless. So left and right are connected. Okay. So this one is the control of the texture level of detail. So for your textures, don't make it too big lah, because you can use the tiling. Okay, especially when you want to have a terrain, right? So the tiling there, okay, so you can make it smaller lah, so no need to be too big. Okay, so this is the procedural texture mapping. We'll learn it next week. Okay, this one we next week lah. Is it okay? Yes, we'll do tutorial for next week tutorial. Okay, so we'll do the procedural texture mapping using the shader grapher. Okay, so our class dismissed lah. Thank you everyone. So